In this video, we're going to talk about direct variation. And direct variation is a special relationship between an x and y variable. So we're going to look at how to identify direct variation. We're also going to look at writing direct variation equations. So a direct variation is a relationship where y varies directly with x. What this means is as x increases, y increases. As x decreases, y decreases in the relative same amount. The form will look like this: y is equal to k times x, and it is so the form of a line with a y-intercept of 0. And so if you have a line where y is 0, the y-intercept is 0, that is direct variation. So something like y is equal to 8x, or y is equal to negative 2x, or it can be a fraction too. It could be like 1/2 x. These are all examples of direct variation. If you had like y is equal to 2x plus 1, or y is equal to x plus 3, those are non-examples of a direct variation. Also, although we haven't really looked at this yet, but if it's not just y to the x, if it has a different exponent or another type of function, it's not direct variation. So to first identify these, we want to solve for y and just see if there is a y-intercept that is not something other than 0. So here, if we add x to both sides, I get y is equal to x plus 1. And so because this is not 0, this is not direct variation. So this is not, we'll use dv, direct variation. This is y is equal to negative 2x. So the y-intercept is 0, so this is direct variation. So this is direct variation. And the constant of variation is the slope of the line. So the constant of variation is negative 2, and we'll use k for that. K is negative 2. So we use k for the constant of variation, and that's a pretty common letter. You could use any letter you want, really. And notice remember we used m for slope. So k and m kind of mean the same thing in this case. Here, when you subtract 4x from both sides, you get negative 5y is equal to negative 4x, and then divide by negative 5, so y is equal to 4 over 5, because the negatives will cancel or divide to 1. And so this is direct variation, and the constant of variation is 4/5. So what does the constant of variation mean? Well, let's look at these, talk about these two just a little bit. So what this means is as x increases by 1, the y value is going to increase or decrease by 2 because it's negative 2. What this means is as x increases by 1, the y value is going to increase by 4/5. What's probably easier to say is if x increases by 5, y is going to go up 4. But once again, relate this directly to slope. And so if you relate this directly to slope, then in a lot of ways, this concept of direct variation is just a more simpler version of graphing lines, because all of our lines will just have a y-intercept of 0. So we have a little bit of an easier starting point. So to graph this, my y-intercept of 0, and then use your slope. Your constant of variation is 2/5. So every one, it's going to go up 2/5. Or we can think up 2 over 5. So go up 2 over 5 and put a point there, and then connect those lines with a straight edge. Here, your y-intercept is 0. It's direct variation, so your y-intercept is 0. There's also nothing out here. It's just plus 0. And use your slope again, or your constant of variation. We're going to go down 3 over 2. So for every 2 increase on the x, my y is decreasing by 3. And then connect those with the straight edge to make your line. Okay, so if we can also identify direct variation from a graph. So first, we want to make sure it's direct variation. So is it a line? And yes. And is the y-intercept 0? And yes, this is true for both of these. So this is direct variation. We have a linear function that goes through 0, 0. And so now we got to figure out the slope. We can use the slope formula where we have a coordinate plane. So let's just count. We're going to go up 3 and over 2. So we go up 3 and right 2. And so that means my k value is 3 over 2, making my equation y equals 3 over 2x. One of the hard things with direct variation is just remembering what it means when it says that the variables vary directly. So if you can just memorize when it's varies directly, there is no y-intercept and it is a line, you'll be in pretty good shape. Okay, so let's see if we have direct variation or not. And we'll use the same test. So first, is this a line? It looks like a line because every single time this increases by 2, so these are increasing the same amount on the x value, and the y value is moving the same amount as well. However, when I plug in -1, I get, my 0, I don't know the value of yet, so we have to figure out what it is. So if I think, what would the point 0 be? Well, it would be 1. What you really can kind of realize is that it's not going to be 0 because that's already taken. And so this is not direct variation because the y-intercept is not 0. In fact, the y-intercept is 1. Okay, and then looking at this next table, we don't see what the y-intercept is, so we got to figure that out. So what would it be if x is 0? We'll add another column to our table. Let's look for a pattern. So here these are apart by 1 each time. So if I'm apart 1, then my difference is 3 and 3. So I can see this is a line, but it skips around. It skips down to -1 and up to 10. Let's ignore this for now, although you might want to make sure that it's linear. We'll assume it is. And let's just look at -1 to 0. So that's going to go up a distance of 3 and make the y-intercept 0, 0. Now this is kind of tough. You could also plot these points if you want to kind of help you see the pattern and help you see that the y-intercept is 0. So this is direct variation. So we have direct variation. And so now we need to find our constant. Well, that's how much it changes for x for each increase of x, or how much the y changes for each increase of x. So we've kind of already figured that out because we said in between 3 and 4, I go up 1. So I'm going up 3, excuse me. So it's going up 3 over 1. So k is 3 over 1, or just 3, which makes your equation y equals 3x. And if you're not sure, you can check, right? And it's pretty quick to check with direct variation because you have no y-intercept. So just plug in the values. If I plug in -1 to x, I get -3 when I multiply. That's right. When I plug in 3, I get 9. When I plug in 4, I get 12. 5, I get 15. And 10, I get 30. So all my values check out. My equation must be correct. Okay, and then if you're given an x and a y value, you can do this a little more algebraically. And so the nice thing about this is it'll be the same every time. But when I mentioned this earlier, you're told that y varies directly with x. And one of the hardest parts about direct variation is remembering that if that's true, then you use this equation. So as soon as you know it varies directly, then you know this is true. And now to write the equation, if you know x and you know y, you can solve for k. So first is just to use this. Second would be to plug in x and y. And that'll be given to you somehow. It might be a point on a graph. It might be just told like these are directly to you. And then you solve for k. And then you can write equation. The good news about this is the solving is going to be the same every time because this formula or equation you're going to use is the same each time. So it's the same process anyway. And if you get good at this, you can kind of make a shortcut, right? But we'll show our work on this one. So here, if I want to solve for k, I got to divide by 14. So 7 over 14 is equal to k. And that reduces to 1/2. And so your equation is 1/2 x. So once you find k, just plug it back in. And when in an equation, you always want x to be x and y to be y, because those are variables. That way you can use this equation to find any x value or any y value given an x value. Okay, so we got a fraction here, which is a little funky, but once again, we know it varies directly with x, so we're going to say y is equal to k times 1/4. So we're going to multiply by 4 on both sides to get rid of that 1/4, and so 4 is equal to k. And so your equation is y is equal to 4x. Here, I mentioned a shortcut. The shortcut would just be remembering if I want to find k, I want to do y over x. It's rise over run. So you could just do -2 divided by 2 and find k is 1. Or write the equation out, y is equal to kx. And so -2 is equal to k times -2. And so we divide both sides by -2, and you get k is equal to 1, or y is equal to just x. Now, once again, this process only works with this one point because you know that y varies directly with x, because you know this. What that also tells you, that means the y-intercept is 0, 0. So really, when you know this point, or you know this idea or concept, then you know a point, and so you already know 2 points on this line. And this is just a shortcut to get to the equation. Okay, good luck with direct variation. Once again, work to memorize. If y varies directly with x, use y is equal to kx. That's very key that you know that. That's kind of your base, just like this is the definition you need, and everything else builds on that definition. But please reach out if you have any questions.